Hello, Philosophy 102. Okay, we're on to chapter 2 now, which you can see is titled Two Kinds of Reasoning. Um, just a brief overview. This chapter is pretty straightforward, and there aren't going to be a lot of notes. We're going to focus on two main ideas here. So we're going to learn to recognize the general features of arguments. We've talked about this a bit already, premise and a conclusion, right? Or at least one premise and only one conclusion if you want to be really specific. So you already understand that. We're going to distinguish between deductive and inductive arguments. And mostly we're just going to be defining what validity, soundness, strength, and weakness are in relationship specifically to arguments. You guys may have at some point found yourself saying like, oh, that's valid. Or that's sound reasoning, or that's a strong argument, or that's a weak argument, right? We have these words in our common vernacular, and that's okay. But for the purposes of this class, these words mean something very specific in relation to these two different types of arguments. We're not going to focus so much on unstated premises. It doesn't feature a lot in the book. We might talk about them because they come up in real life quite a bit, and it's good to identify that. And we're going to talk briefly about a third kind of argument, which this textbook calls an inference to the best explanation. Some philosophers and critical thinking textbooks and such refer to this as abductive reasoning. It's probably the most common sort of reasoning that we use just in day-to-day life. So we are going to take a moment to look at that. Mostly, though, we're just going to be focusing on deductive and inductive arguments. All right, good stuff. I have a favorite. I have a preference between these two, so they're very different. Okay, so general features of arguments. We'll talk about these things later, so let's just move ahead. So an argument consists of two parts. Told you guys I'd say this a million times. One part is the premise, and that provides the reason for accepting the second part, which is the conclusion. So let's look at what they say is not an argument. All right, we have the statement, God exists. That's not an argument, right? Hopefully you all can see that. There's not really a premise. There's not really a conclusion. Nobody's given us a reason for accepting it. We just have a claim, an existence claim on our hands. So, as the textbook says, that's just a statement. Likewise, this is not an argument. God exists, that's as plain as the nose on your face, right? Just saying something is obvious or obviously true is not an argument. It's just, as the textbook says, a slightly more emphatic statement, right? It's just being more insistent about your claim. So, nor is this an argument. God exists, and if you don't believe it, you will go to hell. I want to keep this idea in our head. We're not seeing premises and conclusions here at all. We're just seeing claims or statements, right? Some people might interpret this threat, if you don't believe it, you will go to hell, as a reason for believing it. But that threat is not a reason for thinking it is true, right? The threat might cause you to believe it, so I guess it can be a reason because you don't want to go to hell in that sense, but it doesn't make it true, right? So it could force you to accept it, but it is not an argument. This is not a premise at all. Let's see what our textbook has to say about it. It just tries to scare us into believing God exists, right? So, fear not. Oh wait, I got excited. I thought we were getting there. This is also not an argument. I think God exists because I was raised a Baptist. So we have an explanation here, right? And the textbook recognizes this. Yes, it looks a bit like an argument, but it isn't. It merely explains why I believe in God, right? Because I was raised as a Baptist. That explanation is not a premise. On the other hand, this is what I was excited about, this is an argument. God exists because something had to cause the universe, right? And we can see that they're structurally similar. They've got this because in there, right? But they're different, right? Hopefully this is jumping out to some of you. The difference between this and the earlier examples, this example has a premise, right, which is something had to cause the universe, and a conclusion, God exists, right? Whether or not you accept it is a totally different issue. They've given a reason for thinking this conclusion is true. Not just, for being scared into believing it's true, but a reason for thinking it actually is true. Something had to cause the universe. Again, whether or not you think these are good arguments is neither here nor there. This could be a reason for accepting this conclusion. And so we indeed finally arrive at an argument, right? More importantly, our reason and intellect can now engage with this, right? What would you say to somebody who is like, I think God exists because I was raised a Baptist? Like, they've given you nothing to argue with. Like, okay, cool, thanks for sharing with me about how you were raised. This, though, we can engage with critically. Okay, so, right, the textbook is going to say this probably seems fairly straightforward. It's okay if it doesn't to you yet, but one or two complications are worth noting. So, conclusions used as premises. A couple of you have asked me about this already, and I think I told you we'll get to that soon. So, the same argument can be the conclusion of one argument and a premise in another argument. This gets a bit convoluted, but bear with me. I think it answers a lot of questions those of you who are more engaged might be asking yourselves. So, premise: the brakes aren't working, the engine burns oil, the transmission needs work, and the car is hard to start. Conclusion: the car has outlived its usefulness, right? And maybe you don't come to that same conclusion, but you can see how we would arrive at this conclusion from this premise, or these premises if we stated them separately. Conclusion 2, we should get a new car, right? In this example, the statement, the car has outlived its usefulness, is the conclusion of one argument, and it is also the premise in the argument that we should get a new car. But we have two separate arguments here. I hope everyone can see that. Clearly, if a premise in an argument is uncertain or controversial or has been challenged, you might want to defend it, that is, to argue that it's true. When you do, the premise becomes the conclusion of a new argument. However, every chain of reasoning must begin somewhere. Scroll down a bit. If we ask a speaker to defend each premise with a further argument, and each premise in that argument with a further argument, and so on and so forth, we would eventually find ourselves being unreasonable, much like 4-year-olds who keep asking why. Every semester when I teach this, somebody who has children is like, I just feel like I'm my kid now. This is obnoxious. That's okay. We don't take it that far. We don't exasperate our interlocutors. If we ask a speaker why he thinks his car has outlived his usefulness, he may mention that the car is hard to start. If we ask him why he thinks the car is hard to start, he probably won't know what to say, right? At some point, we just accept it. So, very briefly, because it doesn't feature a lot in this class, but it does in our lives, and I think this is the most important class you can take to just living in the world. So, let's get to it. Unstated premises and conclusions. Another complication is that arguments contain unstated premises, right? So let's look at this. I should have scrolled up. I'm sorry. Just blind yourself to the bottom of the page. So premise, you can't check out books from the library without an ID. Bill won't be able to check out any books. There's an unstated premise in here, right? If one cannot check out books from the library without an ID, and Bill won't be able to check out any books, we don't really even need to say that Bill obviously has no ID. Right? We're already engaged in this kind of reasoning where we can reasonably fix this argument and just assume this premise, right? Arguments can even have an unstated conclusion, and there's an example down here. We'll scroll back up and get to that other bit in a moment. The political party that best reflects mainstream opinion will win the presidency in 2020, and the Republican Party best reflects mainstream opinion. If a person said this, he or she would be implying that the Republican Party will win the presidency in 2020. That would be the unstated conclusion of the argument, right? Some of you are probably already, because we're coming right up on it, some of you were probably already arguing with this before you even noticed there's not a clear conclusion here, right? These are both premises, right? The Republican Party best reflects mainstream opinion, right? In no way is that a conclusion to this first premise, the political party that best reflects mainstream opinion will win the presidency in 2020, right? These are two disparate bits of information, right? One does not lead to the other. They have things in common, right? They're both about the mainstream opinion. So we can tell that there is an unstated conclusion in this just by looking at the fact that one of these does not lead to the other. We know they're both premises for an unstated conclusion, right? It's implied, which is that the Republican Party will win presidency in 2020. And if you just step back for a moment and look at these things this way, you'll find yourself much more able to engage with them. I think that's about all I wanted to say about these specifically. It's an important thing to note, but I don't want to spend too much time on it. I prefer the more formal things and the things that are going to be ideas that we can build on. So let's pause and scroll down to those. I fibbed just then. I realized I said we would come back up to this little block to talk about briefly. This is worth making note of if you're really struggling to identify conclusions. So when the words in the following list are used in arguments, they usually indicate that a premise has been offered and that a conclusion is about to be presented, right? So the three dots, this ellipse is, whatever follows the words, whatever sentence follows it. So if we see somebody say thus, right? Thus, I should eat cookies for dinner, right? Therefore, I should eat cookies for dinner. Hence, which I have not really encountered in life, but it's worth noting. This shows that. This suggests that. Consequently, so. Accordingly, this implies that. This proves that I should eat cookies for dinner tonight. All of these are going to be like hints that we're about to see the conclusion of an argument. There are tons more. Usually we'd take a moment to discuss them, but just be aware that this is here, and if you're struggling to identify your conclusions, these can help you out sometimes. So they can trick you sometimes too, so you still have to ask yourself, does the premise support, does the thing I think is the premise give me a reason for the conclusion, or do I have it backwards? So there's an example here for anyone who wants to take some more time with this, but I'm going to move on. We have moved on to our two kinds of arguments. Good arguments come in two varieties: deductive demonstrations and inductive supporting arguments. So we're just going to hop right over to our notes really quickly. If you're taking notes by hand, you're going to want to have separate areas for each of the types of arguments, because we're going to say quite a lot about each one. Right, and I'm so sorry. Okay, I'm going to capitalize this because I am neurotic like that. All right, and let's give ourselves some space. Okay, so back to the textbooks. And we might talk about, we'll be adding to both categories as we go. Ways to help you keep these ideas separate. So we're going to talk about deductive arguments first. The premise or premises of a good deductive argument, if true, proves or demonstrates the conclusion. Right, so let's get that in the notes. So, what does it mean to prove or demonstrate? Let's have a bit of a chat about that. I cannot stand this insane font situation. I guess we'll just have to live with it. Apologies. So, oh no. Conclusion. There we go. What does this mean? This means right? The conclusions are 100%. There's no way around them. If the What does that mean? If the premises are true, the conclusion cannot fail to be true. That means that, if these premises are true, there is no possible arrangement of facts such that the conclusion cannot also be true. There's no way out of it. If you're struggling to think of anything that's this certain, philosophers like to use mathematics, right? I have really long fake nails right now. I'm very sorry. Geometry, right? Math and geometry are great examples of it. Let's try to make one. So I'm going to make a geometry kind of argument that's pretty basic. Our first premise is going to be that and our premise 2 is maybe going to be all angles are equal in that object, right? So our conclusion from this can be something like that right, that object is not a square, right? And this probably seems pretty obvious to you, but this is important to recognize. If these things about whatever object we're talking about, this theoretical object, that object has 3 sides and all angles are equal, means that that object is not a square. That's not physically possible. The conclusions are 100%. It's not maybe not a square. It's not kind of not a square. Right? It's not probably not a square. Just simply, that object is not a square. And we can see that if the premises are true, right, whatever we're pointing at, has 3 sides and all angles are equal, that object is not a square, right? So in addition to being, kind of mathematical and geometric, they're also definitional. They rely on our definitions of a square, for example, and sides, and, well, I mean, equality is kind of a mathematical concept, but they're definitionally true based on our definition of what a square is. This object cannot possibly be a square. Another feature that I want to talk about that may make this a little more simple for you guys, it's kind of nuanced, is that deductive arguments reason from the general to the specific. I don't want to confuse you guys too much, but suffice to say that this will make more sense when we start talking about categorical syllogisms, which come much later in the class, but you might notice this feature of deductive arguments. If it's the other way around, it's just not right. So maybe we'll take some time to come up with some examples of arguments that follow this sort of thing more obviously. All right, let's move back to our textbook and get some other facts about deductive arguments. So, right, so we've got this really key concept here, which is validity. And philosophers and mathematicians are always going to be very concerned with how you use this word. It's okay if you just use it in conversation to mean legit or something like that. We understand that, but when we're working on reasoning and arguments, validity means something very specific. An argument is valid if it isn't possible for the premise or premises to be true and the conclusion to be false. So maybe you should have introduced this idea a little earlier, but let's talk about what this means. An argument is valid if it isn't possible for the premises to be true and the conclusion to be false. This might look like the same point. I was trying to emphasize two different points here, right? Because this is not true of inductive arguments, right? And because we haven't looked at those just yet, it might seem like these are the exact same statements, and for all intents and purposes, they are. But that's because only deductive arguments can be valid. We will never use this expression to describe an inductive argument. Validity is a feature entirely of deductive arguments, right? That also means invalidity, being invalid, is a feature entirely of deductive arguments. And this is linked to this idea that the conclusions are 100%, right? Or that they are proven by the premises, or the premises demonstrate the conclusion, right? The thing we want to really lock in is that deductive arguments are certain. Okay, let's get back to the textbook. I jumped ahead a little bit, incorporated the idea of validity before we were ready. Okay, so this may sound complicated, but it really isn't. An example of a valid argument is going to help. So let's just scroll down here and look at our argument. So we've got some premises. Jimmy Carter was president immediately before Bill Clinton, and George Bush was president immediately after Bill Clinton. Conclusion: Jimmy Carter was president before George Bush. Now I'm going to take this over to our notes because we're going to work with it quite a bit. So let's just give ourselves more space. Okay. And I'm going to make these look the way you guys are used to them looking. Oh, there we go. Okay, so I'm going to put a little space between them. Okay, so let's look at what's going on here. Jimmy Carter was president immediately before Bill Clinton, and George W. Bush was president immediately after Bill Clinton. Therefore, Jimmy Carter was president before George W. Bush. All right. One of the things I want to do here is start breaking this down a bit. So how are we going to break it down? Well, I want to get as much detail work out of here as possible, right? So I'm just going to make Jimmy Carter JC. I'm going to make Bill Clinton B. C. Probably be better if I just made them their initial. their first name. We can keep the W in there. My reason for doing this might be clear to some of you guys. If it's not, that's okay, don't stress it. Okay. All right, we are ready to rock and roll. This is a bit easier to look at. Let's also just get this on another line. Okay, so we have these two facts, right? JC came before BC, GWB came immediately after BC. Therefore, JC was president before GWB. And we can even make this more simple. We can imagine that these are the names of, little colored boxes we have in, I took out the wrong bit. Much more simple, right? Our colored box that's JC came before BC. Our colored box that is GWB was after BC. And therefore, we can conclude JC before GWB. This one's obviously true, right? It's just an order of things. You can write these off to the side somewhere if you want to and check it out, right? There's no other way to arrange it. This is I like to put little smiley faces. This is valid. This is perfectly valid. It's thrillingly valid, right? So valid, I gave it a happy face. There's no way for these to be true and our conclusion to be false. Now, what is this nonsense I've been talking about this being problematic? Well, we're going to go back to the textbook for that. And we want to get our eye back on this full statement here. As you can see, it's impossible for these premises to be true and this conclusion to be false. So the argument is valid, right? However, you may have noticed that the premises contain a mistake. Jimmy Carter was not president immediately before Bill Clinton, right? That's a problem, right? So how is it that this is still valid? It is. It's because validity is a structural matter. It doesn't say that the premises are always true and conclusions are always true. Wouldn't that be lovely? It says if the premises are true, then the conclusion must also be true. It doesn't say anything about when the premises aren't true, right? Validity does not concern itself with the truth or falsity of these statements. Particularly, it's interested in the combination of true premises and true conclusions. That's all validity says. True premises always equal a true conclusion. And that's kind of hard to conceive of when we're looking at these sentences that have these variables, and we're talking about presidents, and we want to go look it up in the history books. And that's why I broke it down to this statement, because it's a structural fact, right? This argument has a structure such that the conclusion must be true if the premises are true. So a lot of you aren't going to be happy with that. You're going to hate it. You're like, well, what do I care about validity? Well, hopefully you don't want to be making structurally flawed arguments, right? Invalid arguments. You don't want to be engaged in a kind of reasoning that doesn't reliably lead to true conclusions. If you put the right premises in your argument blender, it's going to spit out something good. It's not its fault. It's not the blender's fault, right? If you put garbage in there. So we want this conclusion to be reliably true with deductive arguments, and that's what it means for it to be a structural point. So let's talk about that thing that everybody gets real excited about, which is, well, okay, I hear validity. I hear what that is. All right, fine, I accept that. But what about, I mean, doesn't it matter that these things aren't true in the world? Well, it does. That's a different category of thing. That is soundness, right? Soundness is when the premises of a valid argument are true. So I'm going to scroll back up just so we can keep our notes tidy. Let's actually keep our grammar the same. Argument is sound when the premises of a valid argument are also true. Like, it's very weird when you have to construct the sentence or the parentheses in the actual world, right? So this idea might interest you more, and I would love to spend more time talking about soundness. Unfortunately, we're not going to spend that much time talking about it because whether or not the premises are true is usually what keeps arguments from just being immediately concluded, right? If you've ever had an argument with somebody, usually they're rejecting, at least a deductive argument, they're usually rejecting your premises. They're saying, well, that's not true, or that never happened, or something of that nature, right? So as a form of reasoning, it's important to understand that we do have a word for that thing you're looking for, but validity is something that we can investigate without, checking everything on Wikipedia or, time traveling to the past to witness it ourselves or some insane thing. And this is why philosophers are more concerned with validity. It would be great if we could, confirm that every argument we make is also sound. We hope we make sound arguments, but it's much harder to check than validity. So I worded that so it sounds like a cop-out. I promise it's not. It's really cool. So let's look at the example of a sound argument. So we have these premises. Bill Clinton is taller than George W. Bush, and Jimmy Carter is shorter than George W. Bush. Therefore, Bill Clinton is taller than Jimmy Carter. Right? So, satisfaction. This argument is sound because it's valid and the premises are actually, like, out in the real world true. Like, if you were going to measure these guys, that would be true. As you can see, if an argument is sound, then its conclusion has been demonstrated. Right? This is the demonstration we were talking about. I didn't get these guys on stage and measure them in front of you. It doesn't mean demonstrated in that sense. It means demonstrated in this sense, right? Where I've shown that if these things are true, then this thing must also be true. I've demonstrated that. Okay, so that brings us to an end of deductive arguments for now. We are going to spend a very long time with them. They're very cool. Just to kind of go over these ideas, one more time before we move on. There we go, get that back on the page for you guys. Okay, so with deductive arguments, the premises prove or demonstrate the conclusion. The conclusions are 100%. There's no way out of them. Right? If the premises are true, the conclusion cannot fail to be true. Some examples are mathematics or geometry. They're definitional, and this has one student pointed this out to me. If you're struggling to keep these straight, actually, there's probably a better way to do this. Deductive arguments are definitional. They both start with D's, right? So, and they reason from the general to the specific. Right? An argument is valid if it isn't possible for the premises, or the premise or the premises to be true and the conclusion false. This validity is only a concept in deductive arguments, and an argument is sound when the premises of a valid argument are true. Right? Unlike this example we had before. And again, these are structural points. Oh no, I just cannot keep this straight for you guys today. Validity is a structural matter. Soundness is a truth matter that follows from that structural matter. Okay, time to move on. I bet you guys are ready, but you don't know how much this is going to matter. This is the thing I would study for sure. We're going to revisit it all semester. It becomes much more important in the second half of the semester. So just understand that we're going to be seeing this again. And as easy as I make the exams, so you still want to lock these ideas in. Okay, with that said, we're going to move on to inductive arguments or inductive reasoning. Okay. So it doesn't really have the differences here. So let's talk about this. So the premise of a good inductive argument doesn't demonstrate its conclusion. It supports it, right? So what does that mean? Well, these arguments are they're probably true. So, and strength is a feature of inductive arguments. So their conclusions are probably true if they're strong inductive arguments. Unbold this and maybe it'll go back to normal. Yep, that's just magical, isn't it, guys? Okay, so whereas deductive are mathematical, these are more scientific. Anyone who has taken the science class or is studying science will know that scientists never say anything, any of their conclusions with absolute certainty, right? They'll say, you know, this is a 99% chance, right? Or, you know, the reason we have large sample sizes in science is so that we can get closer to certainty, right? You might do a study with 5,000 people and your hypothesis is true with 4,000 of them and not with 1,000. Okay, well, I mean, it's not very strong, right? So we would assign a percentage to that, a likelihood to that. And when we make predictions about the weather, that's not based on nothing. It's based on inductive premises that have led us to a conclusion that is probably true. So it doesn't have to be 99% chance. It could be, you know, or like a 50% chance for a weaker inductive argument. Okay, back to the textbook. Okay, so this difference between supporting and proving or demonstrating a conclusion is easiest to see if we look at this argument. So when we put this in our notes, we'll use something that is more local to you guys. So after 2 p.m., the traffic slows to a crawl on the Bay Bridge. Therefore, it probably does the same thing on the Golden Gate Bridge. And these are bridges in the San Francisco Bay Area. So what we have here is we have a time, right? After 2 p.m., the traffic slows to a crawl on the Bay Bridge. It's in the same area, and it's the same time, so we can conclude that, therefore, it probably does the same thing at the Golden Gate Bridge. After all, they're only like a few miles apart, right? This premise supports this conclusion. It doesn't guarantee that it's true, though. So let's also talk about what kind of reasoning is going on here. Whereas, we talked about this, deductive arguments reason from the general to the specific. Inductive arguments reason from the specific to the general. Right? When we were talking about that, a made-up study that somebody did that some scientists did with 4,000 people in it. You study each one of those individual 4,000 people or 5,000 people or however many it is, and you come to a conclusion about what's probably true for all people, right? So you go from the specific to the general. This idea is a lot easier to lock in already at this point than the deductive argument one is. Okay, so I promised you something a little easier than this that makes more sense. So bear with me. I'm going to pause this recording so I can just type it up and you guys don't have to bear. Okay, so we've got this big, beautiful inductive argument. And we're going to keep working with this because it allows us to talk about a lot. So you've probably noticed I use roads here in Las Vegas, a bit more familiar to you. And I've stuck with 2 p.m. because whatever, it's 2 p.m. Everything's always busy in Vegas. So we've got Flamingo Road is busy at 2 p.m. Charleston Boulevard is busy at 2 p.m. Sahara Avenue is busy at 2 p.m. Tropicana Avenue is busy at 2 p.m. So we can reasonably conclude probably Spring Mountain Road is also busy at 2 p.m. Right? And we can see quite a few things here, right? I've included the word probably. We won't always have this in our inductive arguments. We don't always encounter it in our inductive arguments in life. And we just don't always include it. You guys are guilty of this too. But we can see that structurally this is a really different kind of argument to the deductive argument. So first of all, let's just get rid of some of these, right? Actually, I'll leave that space in there. Okay, so if I presented this argument to you guys, Flamingo Road is busy at 2 p.m. and Charleston Boulevard is busy at 2 p.m. So probably Spring Mountain Road is busy at 2 p.m. Right? You guys might say, yeah, that makes sense. Those roads are near to each other. They run in the same direction. Why would people just like crowd in on Flamingo and Charleston, but not Spring Mountain? And some of the cleverer ones of you might say, well, or those just more familiar with the area might say, well, Spring Mountain doesn't start until after the 2:15, and I would say, okay, that's true. I didn't think about that. But maybe you'd prove my inductive argument wrong or false, right? It's not a very strong inductive argument, right? It's different to deductive arguments in this way. Let's go back up to our example. Deductive argument. Do I need to add any premises to this to make the conclusion more likely to be true? Can I add any? I just really wanted to make absolutely certain that that object was not a square. Do I really need any help? Well, I've already said the object has 3 sides and that all angles are equal. In fact, actually, I can do this and still come to this conclusion absolutely perfectly. There is 0 chance that if that object has 3 sides, that object is in fact a square. It simply can't happen. I snuck that extra premise in there so I could do this. I'm really excited that it's paying off. Okay, so don't worry about changing it in your notes. It's absolutely fine. Both were fine deductive arguments. The point I want to make here is that with deductive arguments, it's certain, right? The conclusion follows from the premise 100%. There's no way out of it. Whereas, right, if it's valid, there's no way out of it. Whereas with an inductive argument, there are lots of ways this could not be true, right? We could come to lots of different conclusions from this. I could have said probably most of the roads in downtown Las Vegas are busy around 2 p.m. or at 2 p.m., right? These premises do offer support for this conclusion, but it's imperfect, right? So, and inductive arguments also have this feature. Because it's not a 100% yes-no sort of situation, adding more data, adding more premises makes the conclusion more likely to be true. So, this is evidence, right? We can go out and collect more. If we have a relatively unreliable conclusion, if we're just at like 50%, right, we can go out and collect more data to see if that supports our conclusion. If it doesn't, hopefully we change our conclusion, right? We don't want to be guilty of cherry picking, as we talked about last time. But inductive arguments have this feature, and it gets stronger. Strength is not binary. It's not a yes or no sort of thing, right? It exists on a spectrum. So inductive arguments differ from deductive arguments seriously in this facet. Okay. Hopefully you guys are starting to get a feeling for these. Unfortunately, I don't have an easy I word to help you remember this, but if you remember the D's in deductive and definitional, then you don't need an I one. All right, let's get back to the textbook. Very briefly, let's talk about this concept of a reasonable doubt, right? In common law, the highest standard for proof is proof beyond a reasonable doubt. Right? Some of you might take issue with, well, what is reasonable? And to you, I say, good for you. Yeah, right? If you're a juror at a criminal trial, evidence will be presented to the courts, facts that are interested parties, the interested parties, right, the jurors, will consider relevant to the crime. Additionally, the prosecutor and the counsel for the defense will offer arguments connecting the evidence to, or disconnecting it from, the guilt or innocence of the defendant. Right? We have this concept. We understand reasonable doubt, right? And the jury is in fact told that you can't find the defendant guilty unless the evidence proves guilt beyond a reasonable doubt. So you're probably looking at that word right there. Let's highlight it. Right? Again, when using the word proves in common language, this is perfectly fine. But it's important to understand that when we talk about deductive arguments, proof beyond a reasonable doubt is actually a lower standard than a deductive demonstration, right? Because it is actual proof. It is 100% certain, right? Deductive demonstration corresponds a bit more to what in ordinary English might be expressed by the phrase beyond any possible doubt, right? So in logic, a proposition has been demonstrated when it's been shown to be the conclusion of a sound argument, which is an argument in which all premises are true, and it's impossible for the premises to be true and the conclusion to be false. In this sense, many propositions people describe as having been demonstrated or proved, such as the fact that smoking causes lung cancer, or the DNA found at a crime scene was the defendant's, have not actually been proved in the logician's sense of the word. We are using this word differently. We don't mean probably. We mean absolutely. So this all adds up to us having a general sense that deductive arguments crush inductive arguments. But I don't want inductive arguments to get a bad name. There are some other interesting features I just want to take a moment to talk about with you guys. So we're going to go back to our notes. Like I said, we're really just focusing on these two concepts today. There's another feature that we can see in these arguments. So let's put another premise back in here. It's, well, P2, hopefully. It's one that you guys know, and I didn't need to say it because, well, let's keep things simple, and I like modifying our same arguments, but right, squares have 4 sides. That was implicit, right? We talked about the definition of a square and whatnot, but let's make it explicit now. Squares have 4 sides. We're not going to argue with that. Somebody once told me about like a 5-sided triangle that mathematicians had discovered, and like I love math, but I'm not aware of that. So if you know something like that, that's very cool. But for our purposes, let's just go with squares have 4 sides. They don't have any other number of sides. Okay, so the thing I want to point out here is that a deductive argument just kind of rearranges the parts, right? That object has 3 sides. Squares have 4 sides, so we can conclude that object is not a square. There's nothing new about our conclusion, right? It just puts together these facts and comes out with this. So as powerful as deductive arguments are, they don't actually generate anything new. So let's look at this other example that we've kept here to talk about this a bit more, right? You can put nonsense in here, right? We could just even, oh, well, not that simple. We can reduce deductive arguments to just these variables, right? Later we'll call them sentence letters, but for now, right, they're not really sentence letters yet. Anyway, so for now, we're just gonna look at them this way. This is still a valid argument, and it's not because these stand for anything. We could put anything in here, right? Right? This is nonsense, but you'll see it is still valid, right? Joy was before boy, green was after boy, therefore joy was before green. There's no way out of it. If these are true, whatever they mean, this must be true. And you can also see that we don't introduce any new information here, right? It simply doesn't happen. You might have learned something when you come to this conclusion, whatever that means, but it's just rearranging the parts of the premises, which is especially easy to see when we just kind of have nonsense words or letters in here. It's just a rearrangement of these concepts. Inductive arguments, you know, they might not be like mathematics. They might not prove with absolute certainty the thing we're arguing for, but they can tell us something interesting, right? We can look at this collection of facts like scientists, right? And as we add more and learn more, we can add to this, and we can come out with this prediction that's interesting. So it's just not going to be certain. You know, you might get to 99.9 with induction, but you're never going to get to 100. So that's the trade-off. If this idea really has anyone jazzed, please email me and ask me about something called Hume's fork, because these differences in the character of arguments is it's profoundly deep and probably the most philosophical thing in the traditional sense that we'll talk about this semester, right? That's curious. That's fascinating. We can't learn anything really interesting from deduction. We can just rearrange the parts. But induction, we give up certainty in exchange for interesting conclusions. Right? That just absolutely fascinates me. Okay, back to the textbook. Very briefly, excuse me. If you're still having difficulty just instinctively telling the difference, the best thing to do is practice, which is why we're going to have some homework. But another thing you can do is just memorize a valid deductive argument and a relatively strong inductive argument and check out the differences. So feel free to add these to your notes if you want to. Right? Our valid deductive argument is Juan lives on the equator, therefore Juan lives midway between the North and South poles. You'll notice that this is definitional, right? That's the definition of the equator, is midway between the North and South poles, right? Doesn't really tell us anything interesting. Just kind of tells us what the definition of North and South poles are, right? Or of the equator is, which is midway between the North and South poles. So we can see that this is a valid deductive argument. If Juan lives on the equator is true, then Juan lives midway between the North and South poles, also by necessity, is true. We can see that there's no way out of it. It's 100% certain. It has all the features of a valid deductive argument. So go ahead and commit that to memory if you're still struggling. I think practice is a better choice, but to each their own. All right, so now on to our relatively strong inductive argument. Juan lives on the equator, therefore Juan lives in a humid climate, right? So let's look at these examples a bit further, right? The difference between them. Well, it says the left example, but that's because this is meant to be printed. So in the top example, if you know the definition of equator, you already know it's midway between the poles. Right? Nothing new, nothing interesting. And interesting doesn't mean like personally interesting to you. Like maybe you don't care about Juan or like the climate where he lives or any of these things. But it's not novel, it's not new, right? The bottom example in our case is radically different. The definition of equator does not contain the information that it's humid. Right? I'm sure you guys can think of some places along the equator that are not humid, namely places in Africa, right? They're quite dry in that region of the world. So, but most of the areas that fall on the equator where humans can live are indeed humid areas, or even where they couldn't. Maybe he lives on the water. That would be very, very humid. Okay, so if the conclusion of an argument is true by definition, given the premise or premises, it's a valid deductive argument. Right? Often it's said that a valid deductive argument is valid due to its form. Right? I say structure. That's why I demonstrated the one with just letters, or where we changed out colors and boys and joy and all this strange stuff, right? It's just about the structure of the thing. So before we move on to our last little bit, I'm going to show you the textbook's version of this, although it makes me sound quite foolish when I read it. If Juan is a Fraggle Mop, then Juan is a Snippet. Juan is not a Snippet, therefore Juan is not a Fraggle Mop. This is a valid argument. It's not sound, because what do these things mean? I don't know. They don't mean anything. They're nonsense claims. These are nonsense words, right? They don't exist. So what makes this argument valid is its form. And we're going to be seeing a lot of this. So if P, then Q. Not Q, therefore not P. And philosophers like to use P and Q. I will try to keep the letters somehow relating to the sentences, just to make it a bit easier for you guys to learn how to write things in this form. But we can see if we assign P to this first bit, right? Juan is a Fraggle Mop, becomes P. Actually, I wonder if I can highlight these in different colors. You know what I think I should do? Okay, I'm going to highlight this, and then I'm going to underline this. And we can just go through and keep this structure. This really helps. I wish I could use different colors. I'll use different colors next time. Okay. I've not just highlighted little bits because I'm lazy. I've done it because of this negation, this word not in here. So maybe I should do a strike through as well. No. Okay. So now that we've got this color coded, we can go down here and do this exact same thing. Some of you were like, oh, I get it. And we can do our strike throughs as well if we want. Okay, I did include the T in that because I was lazy. That's not special. All right, we can see that these have the exact same structure, right? Yellow, green, not yellow. Yellow, green, not yellow, right? This is a very famous valid argument structure. It doesn't matter what you put into here. If the premises are true, the conclusion must also be true. Now, that's what it means for a deductive argument, or that is what it means to have a deductive argument, and more specifically a valid deductive argument. They're reducible to this kind of thing. You can't really reduce an inductive argument in the same way, right? It relies on the pieces of evidence you have. You wouldn't want to because it's not mathematical, it's not structural like this. So, there's a little explanation of how this works, but, right, the inductive one, we're going to look for evidence. It's not just, we can't make that into little nonsense statements. How would we modify this to try to make it more likely to be true? We simply can't, because deduction really isn't concerned with true in the world in that way, in the way that induction is. So, all right, last bit. I'm going to pause so you don't have to watch me scroll. So, last little bit here, and we're going to be pretty quick. Inference to the best explanation. Definitely not my favorite form of reasoning, but arguably the most common. If any of you guys have watched Sherlock Holmes, be it the new one, the Benedict Cumberbatch one, or maybe you've read the books or watched some of the older renditions of it, you will know that Sherlock Holmes has like almost a catchphrase, which is deduction, my dear Watson, right? People ask him, like, how did you come to these conclusions? How did you figure it out? How did you solve the mystery, Sherlock? And he says it's deduction. He is wrong. It is not deduction. There's one sense in which it is, and I will explain that very briefly before I trash talk Sherlock, who all philosophers love deeply. He does reason from the general to the specific. So in that sense, it has a flair of deduction to it, right? General facts about people to come to the specific conclusion of who did the crime, right? But his form of reasoning is not deduction, it's inference to the best explanation, right? So let's look at an example of this, and this is our safe place because this is the kind of reasoning we're really familiar with. So, neither the dog nor my husband is home, and the dog's leash is gone. The best explanation is that my husband is out walking the dog. Therefore, my husband is out walking the dog, right? This is pretty straightforward. You're making an inference to the best explanation for the facts that you have, right? Could your husband have run out on you with somebody else and the dog because he loves that dog? Absolutely. That would also account for these facts. Is it particularly likely? I mean, we'd need more facts, but let's say probably not. You have a good life, right? Everybody's happy and nothing else is missing from the house. Like, that would be very strange. I just realized how horrifying this example got. Um, so it's the best explanation in the sense that it best accounts for the available information, right? Again, you have a good relationship with your husband, and um, he didn't take anything else, and maybe there's a note on the counter that says, "I'm out walking the dog, honey," right? Does that guarantee that he's out walking the dog with 100% certainty? No, it does not. He still could have taken off um, just out into the wild blue yonder. Oh, man. Okay. But probably he's just out walking the dog. Right? So that's abductive reasoning or inference to the best explanation. Let's look at one more and then we'll be done because I really don't have a lot to say about this. Sometimes my back really aches. Let's see. Could it be due to gardening or lifting weights perhaps? No, it hurts all the time. Plus, it seems to hurt more in the morning, and it started right after I bought that expensive mattress. Expensive mattresses. Therefore, it's the mattress that's hurting my back. Okay, I'm sorry, I'm still laughing at just how sideways my discussion of the other example went. Let's get it off the page. Okay, something interesting is happening here, and that's why I wanted to take some time with it. So we have sometimes my back really aches, and then our speaker considers different possible explanations. Could it be due to gardening or lifting weights, perhaps? And then they dismiss that explanation because their back hurts all the time and they're not always gardening or lifting weights. And then we get this extra bit of information. Plus, it seems to hurt more in the morning. And it started right after I bought that expensive mattress. Therefore, it's the mattress that's hurting my back, right? So we can really see in this example, I didn't have to go to that dark place with the other one, I could have just used this one. We can really see in this example why it's called inference to the best explanation. Because these are, in fact, possible explanations. You know, maybe somebody pinched a nerve doing these things and it continues hurting even when they're not gardening or lifting weights, right? But we then add in, you know, it started right after I bought this expensive mattress. Okay, so that kind of goes against the pinched a nerve hypothesis. And we can reasonably come to the conclusion that the mattress is hurting my back. Right? You can see it's got a little, it doesn't really have a little bit of both style argument. It's just a balance of considerations, right? And with these sorts of arguments, we are very receptive to being wrong. And it's really important to recognize that if we got some other piece of information, like maybe this person went to the doctor and they did an x-ray and they found like something stuck in their spine. God, these all get so dark. They found something stuck into their spine and they were like, yeah, that's definitely what's hurting your back. It would then be foolish with that additional information to say it's the mattress, right? Darn that expensive mattress. It'd be foolish because that would no longer be the best explanation for all the available information. So this one should be pretty straightforward, but they do have some other examples in the textbook if you want to take some time with them. It's included in our homework, but we're really not going to talk about it a lot after this because the thing to do with abductive reasoning or inference to the best explanation is just recognize that it's pretty tenuous and we really need to be flexible when we come to conclusions based on this kind of reasoning. So, all right, thank you guys so much, and I will see you next time.